Okay, so number one, we're going to find, we've got the circle, we've got a formula for it, and our first job is to find the equation of this sector in the form y equals f of x. So we just basically need to take the x squared plus y squared equals 9, and we need to solve for y. So got y squared is 9 minus x squared, and then y is going to be the square root of 9 minus x squared. And happily for us, it is the positive version of this and not the negative version of this. And that's going to be our function. If you want to double check it, go graph it on Desmos. It looks like this. And notice we only care about this portion of it, but that is the function that we're after. Okie doke. So let's get that out of the way. Okay. Second thing is we're going to write an expression for this as a definite integral. So for this part, which I will circle in blue so you know what I'm talking about, it's going to be integral from 0 to 3. And the reason it's 0 to 3 is that our lower bound here is 0 and all the way up to 3, which is our upper bound, of the square root of 9 minus x squared dx. And as I mentioned in class, do not forget this dx. It is super important. Okay. And then B and C, we're going to use a spreadsheet or other technology. You can use Desmos. I'm going to do that. You could use a spreadsheet if you want to. You could use your calculator if you want to. But I'm going to make it do, I'm just going to take screenshots in Desmos. So we're going to 0, a half, blah, 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 blah. That's what we're going to do. Okay, and here's me doing that. What I did was I just named my function f, and I did restrict it. You can't see, but there's like less than or equal to 3 with a curly bracket there. So it's just showing me this particular section, and I added my 0, a half, and notice it's like graphed all of those points for me. So we have all of those points. Awesome. So we have those available to us. I'm going to sit over here. And then it says, use the table and the following diagrams to calculate the sum of the area of the rectangles based in that lower bound. So if we pick the lower bound of this, what we're going to be doing is we're going to finding the area of each of these. Now, notice our dx in this case is a half. So what I'm going to do is I'm going to take each of those values. So like that first value would be a half. So f of a half times 1/2. So that first, this one right here would be f of 1/2 times 1/2. And then that second one would be f of 1 times a half and f of 2 times a half. So really what I'm going to do is I'm going to go back to Desmos, and I'm just going to I'm going to add another column right over here where I say take this value, multiply it by half, and then we're just going to add those up. Okay, so what I did was I just added this extra thing. You don't actually need these dots. They're not actually that important. But I just took a half, I know it's a little bit hard to see, and I multiplied it by all of these values. And so I ended up with, for a half, because really what it's asking for in this case was these green rectangles. And the first one is when I evaluate at a half. So I just used this one. And then, so it's 1, 2, 3, 4, 5. So it's really going to end up being these 5 values that I summed, and I got a total of 6, 13, 14, I guess if you're rounding. Okay, the second part wants you to add up these red ones. And in these cases, what we're going to end up doing is we're going to use the left bound. So instead of using this point right here, I'm going to use that point right there, which is 3. So it's like this value right here. And then I'm going to multiply by half. So what I'm going to end up doing is getting a slightly different set of values. Let me show you what that looks like. So this first one right here, this is just 3 times a half, which you'll notice is right here. And this is kind of important to note. This one right here and this one right here end up being the exact same because they're both using that coordinate right there, which is right above 1, right? So really what we're going to end up doing is we're going to end up selecting all 6 of these. It's just that this is my first rectangle here. R2 is the same as R1. R3 is the same as R2. R4 is the same as R3. R5 is the same as R4. R6 is the same as R5, etc., etc. And so I'm going to select for these, all of these, which really is just going to end up giving me this value plus 1.5. So I don't know what that is. So 1.5, which would just get me 7.639 as my total for that second, this one right here, for the upper bound of the section. And then we're going to find the mean, so I'm just going to average those two, which ends up getting us 6.754. And then it wants us to find the percent error by actually evaluating it, which is not so bad. Since this is a quarter circle, you guys, one way to do this is for you guys to literally just take, that's got a radius of 3, so 3. So you've got pi times r squared divided by 4, because there's 4 parts of the circle. You're going to get that that is pi times, that is 7.068, so 9, rounding, whatever. And then it wants to know the percent error that we've got. And so just dividing it out here, what we've got is we've got the actual area, the fake area divided the actual area, and we ended up with that this is 95.5% accurate. So we're off by about 5%, about 5% error. Cool. Let me know what questions you've got. I know this is kind of messy.